Hi. Let's learn about the law of large numbers, what it is, how it's used, examples. The law of large numbers, in probability and statistics, states that as a sample size grows, its mean gets closer to the average of the whole population. This is due to the sample being more representative of the population as the sample become larger. In a financial context, the law of large numbers indicates that a large entity which is growing rapidly cannot maintain that growth pace forever. The biggest of the blue chips, with market values in the hundreds of billions, are frequently cited as examples of this phenomenon. The law of large numbers can refer to two different topics. First, in statistical analysis, the law of large numbers can be applied to a variety of subjects. It may not be feasible to poll every individual within a given population to collect the required amount of data, but every additional data point gathered has the potential to increase the likelihood that the outcome is a true measure of the mean. The law of large numbers does not mean that a given sample or group of successive samples will always reflect the true population characteristics, especially for small samples. This also means that if a given sample or series of samples deviates from the true population average, the law of large numbers does not guarantee that successive samples will move the observed average toward the population mean. Second, the term law of large numbers is sometimes used in business in relation to growth rates, stated as a percentage. It suggests that, as a business expands, the percentage rate of growth becomes increasingly difficult to maintain. This is because the underlying dollar amount is actually increasing even if the growth rate as a percentage is to remain constant. If a person wanted to determine the average value of a data set of 100 possible values, he is more likely to reach an accurate average by choosing 20 data points instead of relying on just 2. This is because there is greater probability of the 2 data points being outliers or non-representative of the average, while there is lower probability in all 20 data points being non-representative. For example, if the data set included all integers from 1 to 100, and sample taker only drew 2 values, such as 95 and 40, he may determine the average to be approximately 67.5. If he continued to take random samplings up to 20 variables, the average should shift towards the true average as he considers more data points. In statistical analysis, the law of large numbers is related to the central limit theorem. The central limit theorem states that as the sample size increases, the sample mean will be evenly distributed. This is often depicted as a bell-shaped curve where the peak of the curve depicts the mean and even distributions of sample data fall to the left and right of the curve. In a related manner, the law of large numbers also states that data is refined as the sample grows. However, the law of large numbers more closely relates to the center of the bell curve. The law of large numbers indicates that as a sample size increases, the mean of the sample will more closely resemble the mean of the population. Therefore, the law of large numbers relates to the peak of a curve, while the central limit theorem relates to the distribution of a curve. In business and finance, this term law of large numbers is sometimes used colloquially to refer to the observation that exponential growth rates often do not scale. This is not actually related to the law of large numbers, but may be a result of the law of diminishing marginal returns or diseconomies of scale. The same principles can be applied to other metrics, such as market capitalization or net profit. As a result, investing decisions can be guided based on the associated difficulties that companies with very high market capitalization can experience as they relate to stock appreciation. This concept is somewhat central to growth versus value stocks, as a company may find it to maintain its business strategy of rapid growth once it achieves market success. Here are 4 key takeaways. 1. The law of large numbers states that an observed sample average from a large sample will be close to the true population average and that it will get closer the larger the sample. 2. The law of large numbers does not guarantee that a given sample, especially a small sample, will reflect the true population characteristics or that a sample that does not reflect the true population will be balanced by a subsequent sample. 3. The law of large numbers indicates a bigger sample will represent a population mean, while the central tendency theorem states a bigger sample will represent a population's distribution. 4. In business, The term law of large numbers is sometimes used in a different sense to express the relationship between scale and growth rates. Hope this would help. Thanks for watching.